This is the conclusion to lesson 6.5, where we're going to apply what we've been learning in chapter 6 to solving word problems that involve quadratic equations, and we all love word problems. So when you're solving a word problem, there's some basic suggestions that I'd like to make with regards to them. First of all, you've got to make sure you read the problem carefully and make certain that you understand the meanings of all the words. Be especially alert for any technical terms that are used in the statement of the problem. And I often find myself underlining or highlighting those technical terms. Second, read it again. Make sure you haven't missed anything to get a good picture of the situation and the problem that you're trying to solve. Third, and probably most important of all of this, is to draw a picture if necessary, or a diagram or some sort of chart that might help organize the information that's provided. Fourth, choose a meaningful variable to represent what you don't know. Like if you're trying to find the length of a rectangle, you could use L to represent length. Then look for some sort of a guideline. Like if we were talking about the area of a rectangle, then you've got to think about the fact that finding the area of a rectangle can be done by multiplying length times width. Or if you're talking about the area of a triangle, well, then you're going to need to take half the base times the height. So that's what I mean when I say look for some sort of a guideline to get an equation set up. Then form that equation and then solve that equation. So let's demonstrate here with this example. A page for a magazine contains 70 square inches of type. Now right away, as I'm reading this, 70 square inches jumps out at me. I know square units are always about area. And so I'm underlining that and drawing attention to it as I read this information. The height of the page is twice the width. So the height of a page is twice the width. That's important also because it gives me an idea of how height and width compare. So I can tell that I'm going to have a variable that relates to one or both of those. Height doesn't equal, not weight, but height doesn't equal width. But basically we see that the height is twice the width. So if I want to find the height, I can just take the width and double it. Okay? If the margin around the type, so the margin around the type on the paper is to be 2 inches uniformly. So you've got a 2-inch margin on top, a 2-inch margin on bottom, on left and on right. What are the dimensions of the page? So dimensions have to do with height and width. So first I recognize that I'm given some information about the area, and then I recognize that I'm also given some information about how the height and the width compare, and I'm wanting to find those dimensions. So here's a picture that sort of represents the information provided. I've drawn, well, I didn't draw it, but I've got a rectangular piece of paper here, and what I decided to do was call the width X. Then the height we knew had to be twice as large, so it had to be 2x, okay? Now you might use W and 2W. That would make more sense, but it doesn't matter what variable you use as long as you use a variable and are consistent in its use. Then you also notice that I enclosed the type in this border that we were told is 2 inches in diameter, or 2 inches in width, excuse me. All right, so now we've got to consider the fact that the area of a rectangle, I'm going to change colors here. Okay, the area of a rectangle is found by taking that length times width or height times width. So in our case here, the original height of the paper is 2x, but I have to remember that I don't have this 2 inches, nor do I have this 2 inches for type. I've got to take those 2 inches, those 4 inches away. And so I could represent the height as 2x, which is the height of the paper, but take away the 4 inches that I cannot put type in because those are the border. Let's do the same thing with the width. The width is originally x, but once again, I've got this 2 inches and this 2 inches that don't have any type in them. They're the border, so I've got to take away those 4 inches. So the width will be x minus 4. So what's in red represents the height or length of the rectangular piece of paper, the part for type, and what's in blue represents the width. So now what I'm trying to do is find x, so it would make sense that at this point I would now FOIL. First times first would be 2x squared. Outside times outside would be minus 8x. Inside times inside would be minus 4x. And last times last would be plus 16. If I combine these like terms, I have 2x squared minus 12x plus 16. Now I have to remember now that that represents the area of this part of the paper that I have for typing. And so I was told in the stem of the problem that the area was 70 square inches. So all of that is equal to 70. So again, I'm working towards trying to determine the value of x. So what I have is this area equation. So we learned in lesson 6.4 that what we need to do is get this equation in standard form so that we can then use one of our methods, either factoring or the quadratic formula or completing the square, to solve for the missing variable. So to get it in standard form, I need it to be equal to 0. So I'm going to need to subtract 70 from both sides of my equal sign to get it to equal 0. Okay, so now my equation is in standard form. Now if I chose to use the quadratic formula, I need to know the value of a, which is the number in front of the x squared, the value of b, which is the number in front of the x, and the value of c, which is the constant, the term that does not have an x. And I plug those into my quadratic formula. We practiced that quite a bit in class the other night. Another option would be to complete the square. And in this case, I could complete the square, but remember, you start in completing the square by dividing every term by the number in front of the x squared, by the a. Well, in our case, a is 2, so I need to divide everything by 2. 0 divided by 2 is 0. 2x squared divided by 2 is 1x squared. Negative 12x divided by 2 is negative 6x. And negative 54 divided by 2 is negative 27. So if I'm completing the square, that's step 1. Step 2 then is to move the constant back to the other side. I had to have it equal to 0 to use the quadratic formula, but to use the completing the square method, I want my x and x squared alone on one side of the equal sign and everything else on the other. Now I have to determine what needs to be added to make that a perfect square trinomial, and I'll add the same amount to the other side. So I take b, we remember, I cut it in half, and I square that answer, and that's what I add to both sides. So in our case, b is negative 6. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So I'm going to need to add 9 to both sides of my equal sign. Okay, so I cleared out a little space here. So we added 9 to both sides to make this a perfect square trinomial. So now what happens is on the right side of the equal sign, that factors down to a binomial squared. And of course on the left side, 27 plus 9 is 36. The way I determine the values in the binomial squared is I square root the first term, I square root the last term, and I bring down the sign in the middle. So now I've got x minus 3 quantity squared is equal to 36. I'm still trying to solve for x. I've completed the square. To get rid of the squaring, I'm going to need to square root both sides. And remembering every positive number has 2 square roots. So when I square root the right side, I'm left with just x minus 3. When I square root the left side, I'm left with either positive or negative 6. Finally, to solve for x, I'll have to add 3 to both sides. And I'll have x is equal to either positive 6 plus 3 or negative 6 plus 3. In this case, though, the negative value doesn't make any sense because I've got to remember that what x represented was the width of the paper, and width can't be negative. So we've determined that the width is equal to 9 inches. The length, we said, was 2 times the width, so it would have to be 18 inches. So there I've solved for x and then found length from there using the completing the square method. So I could either use completing the square, I could use the quadratic formula, or I also could go back and I don't have to use all three, I'm just showing you all three so you can choose which you prefer. I can go back to my standard form equation after I divided by 2. And I could factor it. Okay? If I factor it, I can use the unfoiling method here. I know that I need to find two numbers that when multiplied together they equal negative 27. Well, that means one has to be a positive, the other has to be a negative, but they have to add to negative 6. Well, that would be negative 9 and positive 3. So my factors would be x plus 3 and x minus 9. If I apply my factoring theorem that we've used previously, I've got two things multiplied together that equal 0. So if either of them was equal to 0, we'd have a solution. So you set each factor equal to 0, and you solve for x. Here, x would be equal to negative 3 because we'd have to subtract 3 from both sides. And here, x would equal positive 9 because we'd have to add 9 to both sides. So you see it produces the same answer, 9 inches for width and therefore 18 for length. It's just another method of getting to that answer.